So hello and welcome everybody, this is Sarim Khan, and today since I am back with the third video of Newton's laws of motion. So since laws of motion already two videos I have already made, and today is the third video. Today is the turn of third video for the Newton's laws of motion. So first of all we can know what points we are going to study today. First of all today we will study about FBD or the free body diagrams, and after that we will try to study about the resolving of a force, what is meaning of resolution of a force, and after that we can study about the coplanar forces in equilibrium and then concurrent coplanar forces in equilibrium. So those 4 points today we will together be studying. So first of all we will start from the free body diagrams or the FBDs. Then here we can write here FBD. So first of all question arises that what is a FBD? Since if any book you are using, if that is also NCERT, so you can study that if in forward later chapters you are going, so easily you can see that there would be many points related to FBDs. Many times they draw little different type of graphs if you are seeing the solution of any question or the examples. So there are some different kinds of graphs or diagrams drawn, such as sometimes it may be possible that suppose you have a surface on which a block is kept of mass m. Later what it is done? Later it is written that the FBD of this will be of course like this. First of all this is present, so this is downwards with mg, this is like this, and so actually what are those? So those are generally known as the free body diagrams. So what are free body diagrams? So free body diagrams is that those kind of diagrams in which all the forces on a particle is present. Okay, all the forces of the particle are shown there. So actually generally free body diagrams consist of the system or the particle on which forces are to be applied, and later it directly writes the or shows the all the forces acting over that. Means it generally helps us to justify how many forces are acting and which kinds of forces are acting. So generally like this we can easily make free body diagram. But sometimes question arises, of course really very nice question, if it shows the all forces acting over the particle, but actually how to draw it, how to draw a free body diagram? So easily it is very simple. Just like I have already said you that suppose here we have any kind of mass and I kept it over the surface, any block of mass m which is kept over the surface. Later my friend asks me to draw the free body diagram of this kind of block. So later I will draw the free body diagram such. Why such? Because what are actually the forces acting over the block of mass m? First of all its mass is m, so there will be a force called the weight. Since weight is mg, since what is actually weight? Okay, weight we can easily define that the force of attraction by which the earth attracts any object. Just like since we have studied a formula that F is equals to G m1 m2 by r square. This we have studied. Now scientists say that suppose that the m1 is replaced by m, suppose it is replaced by m, single capital M, or if we are also writing here m1, so suppose that this m1 is the mass of earth. We are finding out the force between mass, okay, between the mass of earth, between earth and any particle. So one place will be putting about mass of earth and the other place mass of the particle. So later scientists say that this quantity gm1 by r square will thus be called the acceleration due to gravity. So generally if we are seeing this, so generally at the place of m1 it is written m, so we can easily write here m also. If you want m you can write, or if you want m1 we can write. So gm by r square, where g is the universal gravitational constant, r square we can call that the distance between the particles, or you can also call that in this case we can call it is the radius of the earth. So r square radius of earth is squared. Later this is the mass of earth easily. So its approximate value is 9.8 meter per second square, approximate value. So always in every case it is constant value, 9.8 meter per second square. Why meter per second square? Because it is acceleration due to gravity. Suppose under free fall, this marker is in my hand and I just leave this marker. So when I will leave, so it shows whenever I will be leaving this marker, so earth will be attracting this marker, and then earth will also accelerate the marker. Means in 1 second, what will be the velocity attained by the marker? In 1 second, 9.8 meter per second, or the acceleration is 9.8 meter per second square. So according to this, if I do, this quantity is g, so if I write that gm2, or suppose that this m2 I am replacing by m, so what is actually gm we can also write as mg. Gm and mg are same, so this I write as the weight. Okay, because W equals to mg, which is equals to again gm m divided by r square, means that force by which earth is attracting any particle. So mg is generally weight of the particle. So this is also force of attraction. Then this is a force. I am putting it downward, mg. Later, generally from the center we have to do. First of all, we will mark a point at the center of the particle, and from there we have to draw the forces. Downward direction mg. Later we learn that, imagine since this is the surface, so surface will try to push the block towards upward direction, so there will be caused a force due to this, that is known as normal force or normal reaction force, normal contact force. So that is represented by n. So it is just where it is of course upward, so here this is upward. So this is the correct FBD of this kind of particle which is kept over the surface of mass m. This is the correct free body diagram. Or if you have to understand better, so we can take another example. Suppose this is a circle, suppose this is any ball of mass m. Later what happens, that it is kept under the two walls. Okay, it is lying between two walls or two surfaces. After that what happens, that I say to you to draw the correct free body diagram of this mass. Okay, since by seeing it is looking very complex, it looks very complex, that it is not kept over the surface, it is kept between two walls, okay, or two surfaces like this, and inside the ball is present. So of mass m. So by seeing it looks little complex, but it is really very easy. Only what you have to do, you have to draw the ball. Done. After that, mark the point from the center. Done. And where is the weight? Weight will not be here, not be here, always here. Just like example, let us take. Suppose this is an inclined plane. By making angle theta, angle of inclination is theta, and here I am putting any block of mass m. Later, where will the weight of the block of mass m be? Okay, of course we know that it is always here, mg is always here. Since mg will be not at mg cos theta, not at mg sin theta, mg will always be down, because earth is attracting any object just in a straight line, never at cos of angle theta, never at sine of angle theta, always just in a straight line. If we are putting this marker such, then also its weight will be here. If we are putting marker such, then its weight will be here, and if we are putting marker such, then also its weight will be just in a straight line. So actually then in this case also mg will be down. Done. After this we can easily see that the ball of mass m is not kept over the surface, because it is lying between two surfaces, it is not at the surface. So here where the normal reaction forces will be applied, we can see that this will apply a normal reaction force n1, and here n2, because here when it was here, so any force n was getting applied, but the walls will try to push it here, and this wall here. So here n1 will act, and here n2 will act. So this is the correct free body diagram of this kind of ball that is lying between two walls. Or if you want to say that here any external force is also F, suppose any external force F is acting over the ball, so what will be doing? Here this is the F. So this case may be possible, means whichever forces are acting on the particle, all forces will list up in the F free body diagram. And Then what are the benefits of free body diagram? So mainly benefits of free body diagram can be said, because if we try to write all the forces, all the components of forces, so it becomes very easy to solve any problem, because then more quickly, okay, since we can easily see that this was looking very complex, so if we have to solve any problem related to this, okay, this kind of system, this ball, so it becomes very complex. But if we can draw the free body diagram of this ball, means this, so from here easily we can do any problem. So this helps us make the problem easier. So that's why we can easily draw the free body diagram, and then if we try the same problem, so it becomes very easy. Now as we have learnt the free body diagram, how to make the free body diagram, let's move to our next point, that is resolution of a force. So first of all we'll be rubbing it. Okay, so now we'll discuss about the resolution of a force. So we can also write here. Okay, so first of all, force already we have discussed. Now we'll be discussing about the resolution of a force. So what actually is meaning of resolution of a force? So if we have any, suppose if we have any force F, and we are writing the x component of F and the y component of F, it means the forces resolved. So if we want, so we can easily understand it by a better example. So suppose I am saying that here I have any block of mass m that is kept over the surface. Later what happens, I from here apply the force, okay, F on the block of mass m, okay, by making angle theta with the horizontal x-axis. Suppose the angle is getting made theta. Later any my friend says to me that can you resolve this force, or he says can you find out the x component of this force and y component of this force. So how will I do that? Okay, how can we do that? So easily, first of all, this force we can do. So first of all, this force is acting here on the particle. If we want its okay, free body diagram we can make. Force is acting on the particle. Later what is that this angle is said to be theta. This angle is theta. After that what will happen? I have to find out the x component. Since for better understanding we can make this okay, look little bigger. Suppose that the angle is little bigger. This is the force getting applied here by making angle theta with the horizontal x-axis. Now we can little more clearly do it. So here is the horizontal y-axis. This is x, y, and this is negative y, and this is negative x. This we can have. Now here we can see angle is getting made theta, and my friend says find out the x component of this force and the y component of this force, or he says that resolve this force. It means find x component and y component of this force. So what I will say, that the x component of this force is f cos theta, while the y component of this force is f sin theta. Why it is such? Because if we know the laws of trigonometry, rules of trigonometry, then easily we can solve this problem. Because since we know sometimes trigonometry is very useful tool in physics. If one knows trigonometry, so he can solve many problems in physics. So by applying the laws of physics, okay, sorry, mainly trigonometry, if this is f and this is theta, then this will be of course f cos theta. Means fx, or the x component of this kind of force f, I can write as f cos theta. How it came such? Because of course, what is the value of cos theta? Cos theta I write as perpendicular divided by, okay, so generally, sorry, I write as base divided by hypotenuse, base by hypotenuse. If I make a right angle triangle from here, what is actually base here? Base is f cos, okay, generally f cos theta, but we already didn't know it is f cos theta. So this I write as, generally let me write same as base divided by hypotenuse f I had. So b by h implies that cos theta is what? B by h, b by h. So according to this, if I do cross multiplication in this, then b is equals to what? H cos theta. Okay, Generally, here is F. Okay, so F cos theta. Okay, B is equals to what? F cos theta, means my base in this right angle triangle is F cos theta, and my base actually was the x component of this force. So that is again F cos theta. So if one knows the rules of trigonometry, then he can easily do this problem. Since it is said that mathematics is a very important tool, okay, for solving physics, and generally H.C. Verma sir, who is really a very great Indian physics book writer, so he has even written in his book of concepts of physics, that is really very famous book, okay, in chapter number 1st, introduction to physics, and on page number 1st in that book, that mathematics is the language of physics. So generally mathematics can make physics easier, so that's why here we can also just prove it, because once we used mathematics here, so every other problem becomes very simple, since mathematics little we applied rules of trigonometry, and easily we get that this x component of this force is F cos theta. And if one knows more mathematics, then he can tell that this will be F sin theta. Of course, how F sin theta? Suppose this is angle theta, then this will be 90 minus theta. Then here we can write that cos 90 minus theta. This is theta then, and this whole is 90, so this will be 90 minus theta. 90 minus theta is again what? It is base by hypotenuse. Cos of 90 minus theta will be base by hypotenuse, and according to this, if again same step we are following, implies that the base is what? Okay, so mainly this we have to tell. So according to this, if we are going base by hypotenuse, so finally this y component also we are getting Fy is equals to F sin theta. So those are two very important rules in physics, that suppose any force, any vector quantity, any kind of vector quantity, any physical quantity is making angle theta with the x-axis, so what will be done, that if we have to find out the x component of that, then we'll do, okay, F cos theta. Suppose that that kind of vector quantity is F, so we'll be doing F cos theta. So sorry, actually power went for some time, so now let's continue, let's resume. So here, since we know when we applied the laws of trigonometry, then easily we get from here that the x component is F cos theta and the y component is F sin theta. But imagine, just like I am giving you an example, that imagine this is the force acting, here is the y-axis, here is the x-axis, and it is making theta, angle theta with the y-axis. Then what is the x component and what is the y component? Then the y component will be F cos theta, not the x component, and the x component will be F sin theta. So with which axis it will be making the angle theta? So to that axis we can call that will be F cos theta, while to the other axis its component will be F sin theta. Suppose it is making theta with x axis, then its x component is F cos theta and y component is F sin theta. If it is making theta angle with the y axis, then y component is F cos theta while x component is F sin theta. So this is mainly called the resolution of a force, and once we have completed it, so now we can move to a new point in this chapter. So our new point in this chapter will be about coplanar forces in equilibrium. So first of all, let me rub this. Okay, so now we'll be discussing together about the coplanar forces in equilibrium. So first of all, let me write here coplanar forces in equilibrium. So first of all, since we know about what are coplanar vectors, since in chapter vectors we have studied that coplanar vectors means those kinds of vectors. Generally it is very simple, those kinds of vectors which lie in the same place. So coplanar forces also very easily we can understand. But what about when there are coplanar forces in equilibrium? What would be the condition of the forces and the particle? So easily we can tell here easily. So only what we scientists are telling us, that suppose any force is acting over any particle, Suppose F1 and F2 are acting. Later what scientists tell? So since we know equilibrium means what? Okay, sigma fx is 0, sigma fi is 0. Means net sum of all components, okay, of x component, y component, sometimes z component, that is all 0. So what scientists say that we can call that the 2 or more, but generally only up to 3, not higher than 3. So if up to 3 any coplanar forces we have, and we can call they are in equilibrium only and only if fx is 0, mainly sigma fx, and sigma fy is 0, and sigma tau about any axis, any kind of axis is also 0. Then we can call that the coplanar forces are in equilibrium. But here since we know, imagine that we have 3 coplanar forces, F1, F2 and F3. Then first of all we'll be finding out the x components of F1, F2 and F3. Then we'll do its sum. Okay, vector product, we'll be doing its vector product. So actually, sorry, that is vector sum. We'll be doing its vector sum. After doing its vector sum of the x component of all the 3 forces, if it is coming 0, vector sum of the y component of the 3 forces is also 0, and the torque about any axis is also 0. Okay, sum of torque about any axis is also 0. Then the coplanar, those coplanar forces will be called in equilibrium. But here a new quantity is introduced. Torque. What actually is torque? So mainly torque is, we'll be discussing in the chapter rotational motion. It's topic of rotational motion. Since in 11th syllabus there is a chapter named as rotational mechanics or rotational motion. In that we discuss about torque. But if it has fallen in our topic laws of motion, then we should know about torque. So we can tell about torque. Generally it is denoted by tau. Okay, by the letter tau. We write it as r cross f. Generally vector r cross vector f. That's why torque is also a vector quantity. What are r and f? So r is the position vector while f is the force. That is again a vector quantity. It is really a vector quantity. So that's why I have put arrows over it. And since vector product of any two vector gives what? Gives a vector quantity. So torque is also a vector quantity. So we can define that r is the perpendicular distance mainly. It is the perpendicular distance. So according to this definition we can define the torque that it is the cross product of vector r and vector f, or the perpendicular distance to the force. Okay, so this is known as the torque. So if torque generally it is said to be about any axis. So if torque about any axis is 0, those two components are 0, then we can call that the coplanar forces are in equilibrium. Since this topic is very easy, okay, this point is really very easy. Only this if we know, it means we have understood coplanar forces in equilibrium. And now we'll be moving next point, that is concurrent coplanar forces in equilibrium. Okay, concurrent coplanar forces in equilibrium. Okay, so actually how can we say that two or more concurrent coplanar forces are in equilibrium or not? So what scientists say that if only coplanar forces we have, then they can be called in equilibrium. If sigma fx is 0, then sigma fy is 0, then sigma tau about any axis is 0. But later scientists say that if we have another kind of equilibrium state about the concurrent coplanar forces, we can call they are in equilibrium or not only by mentioning about sigma fx, that is 0, and about sigma fy, that is also 0. Suppose we have those two as 0. No need to include torque in this. If we are not including torque in this, so no problem. But if still those two quantities are 0, then we can call that the concurrent coplanar forces are in equilibrium. Otherwise not. So generally it is really very important and interesting point to understand. Suppose we have any particle on that two forces we are applying, And later it is said in the problem that both are concurrent coplanar forces and that are in equilibrium. Then we can do sigma fx is 0 and sigma fy is 0. So by finding out the x components of both kinds of forces, later y component of both forces, and first of all we'll add the x component and we'll make it 0, then y component and make it 0. And if f1 is given, then from here we can find out f2. If f2 is given, we can find out f1. So it becomes very easy if we know those 2 points, okay, about coplanar, okay, that is force in equilibrium, and about the concurrent coplanar forces in equilibrium. So this was mainly today's topic based over the laws of motion, part number 3rd. And after today's video, okay, tomorrow we'll have a new video about the part number 4th about the laws of motion. So thank you to you all.